Hello, I'm Verdio Busto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Thank you all for being here. I appreciate everyone coming. Thank you for the love and the support. I needed to do this one. I need to do this one and wrap this puppy up. You can see it's been the 9th. This is, we got to move onward and upward in this. And this is the final installment in this series here of the telluric currents of the planet. Thank you all for being here. I appreciate, again, everyone, your love and your support, your comments since I've been back. I'm sort of back. But I'm working on a website, and I get a lot of other stuff I'm doing with Alex. Thank you all for being here to enjoy this with me. So the Earth electricity, the telluric currents, is what this is about. I've done, like I said, a number of, 8. We're at part 9 now, so there's been 8. And there's a few introductions to this. I needed to do this one so that I could do the live stream on this and do all of them together. And I still got to edit them, so that'll be whenever that happens. Soon, though. I'm soon. I'm feeling up for doing stuff. I'm feeling much better now. And I'm editing these to cut out the little dead space in there. That's something that I'm working with Adobe Premiere Pro, whatever, one of the Premieres. I got it as a crack, in a sense. Any of you that know what that is, you'll dig that. All right, so I got to get through this. I got to power through this. So we're on what's here on my PDF. I'm reading the PDF, and this is my text over here, what's going in the description and on the, sharing, the shareable links that I send it through. This is the table 1. I've already been through that, but I wanted to show this again. All right, and let me get out of here. There we go. All right, so I wanted to show this again, even though I've been through this. These are different. This is simply as a review of this material, of different types of, we're on space phenomena now, but you can see as we're going through this, right, atmospheric, and then space, sorry, we were on space, the last one. Now we're on the atmospheric, and we're going to be discussing these, the TIDs in general here. Okay. Right, so this is where we're at in this coming up. So what on the PDF is 3, is my 9. The way I just have this organized is my number 9. All right, so let me get into this. Okay, atmospheric phenomena. A PDF, section 3. What I have is section 9. All right. Whatever. Oh, you're not going to let me do that. All right. All right. Atmospheric phenomena. Traveling ionospheric disturbances, which they abbreviate as TID. Let me highlight this. All right, there we go. Traveling ionospheric disturbances, TID. Atmospheric compression, i.e., acoustic waves from a sudden event such as an earthquake, tsunami, volcanic eruption, severe weather, or rocket launches can create traveling ionospheric disturbances, TID. The references are, get out of there. Let me pause this for a sec. Okay, I'm back. Catastrophe avoided. All right. And I had just read through that. Atmospheric compression, blah, blah, blah. And so what's interesting about that, I'm just going to pause that and say this. I'm pausing this. I did not know that rocket launches can create traveling ionospheric disturbances. But that makes sense. Okay, so, what I I learn stuff as I go through these as well. Like this is, this is a review of stuff, and I've kind of, a lot of times, I'll put it this way. Often, by the time you get it, I will have read through most of this, and so it's not new for me, but I learn. That's why I like these, because I learned shit. Like, I didn't know that. Oh, okay, all right. So that's just a little side note between you and, the 20 of you who will watch this and me, and no, certainly there'll be more than 20 of you. 25 anyway, I think. All right. Where are we? And these TID can induce telluric currents in the ground via the geomagnetic field. TID are themselves a category of GIC, and if you were here for the last part, that would be global, where is that? Geomagnetically induced currents is GIC. Yeah, because obviously, clearly, I don't know what it was. The ionosphere also has resonant electrical phenomena called human resonances, there we are, at a fundamental frequency of 10.6 hertz with overtones at 18.4, 26.0, 33.5, and 41.1. All right. Now, do you see what's going on here? Did you see what happened? It says fundamental, right? You will notice that it is not, that fundamental is not 7.8, right? The fundamental frequency is 10.6. You got to remember that. The fundamental frequency of the human resonances is 10.6 hertz. Okay, so if Earth has a proper heartbeat frequency, it is 10.6. So when you see on the spectro a hertz frequency of 10.6, and you can't figure it out, what is 10.6? Well, it's the fundamental of the frequency of light. That's its first pass. Is 10.6. Remember that. That's what that is, right? See that? The fundamental frequency. And then there are overtones. There's one at 18.4. Okay. Barang dang chik ta. Okay. So I just want to understand when we're saying this, that there's a deeper, higher, thingamabob going on here. Okay. The background amplitude of measured human resonances is about 1.0 picoteslas, and the references are Schlegel and Fullerkrog in 1999. In addition to the examples given, TID can form as a result of gravity waves at the troposphere-ionosphere interface, and that's George's 1968. That's a reference. A gravity wave is one where buoyancy or gravity or both act to oppose the displacement. A common example of a gravity wave is the wind-generated waveforms one sees at the ocean ocean-air interface. Okay, so it's right at the surface of it. Some TID are akin to these occurring at the troposphere-ionosphere atmosphere. No qualitative reports of the magnitudes of telluric currents resulting from TID are extant, but the best of the author's knowledge through qualitative magnitudes are known. Some of this is difficult reading even for me. Here, I'm trying to read it as I'm going along and understanding it, and sometimes it's difficult to do both. All right. Space weather events are the strongest TID, and then, in descending order, daytime signals, atmospheric compression events, and gravity waves. And that's George's 1968. Okay, and that was the year I was born. The effect of TID within the ionosphere is for the disturbance to develop a potential on the order of 1 millivolt per meter. And this is Shayakawa et al. 2003. Frequency for the ionospheric dynamo region is modeled to be on the order of 10 to the negative 6th to 10 to the 7th hertz. And I'm pretty sure that's not as... I think there's a minus. I'm not sure. No, there's not. Yeah, there's a negative on both of those. All right. Yeah, because it's important. 10 to the negative 6th to 10 to the negative 7th hertz. That's Kaladze et al. 2003. Higher frequencies are also present. Monroe, 1958. Short-term changes on the order of hours to the Earth's magnetic field may be caused by ionospheric activity, and that's Kaladze, again, 2003, have modeled ionospheric activity that matches the magnitude and timing of ground observations of changes to the magnetic field. I am so glad that I'm putting this out as a shareable link for you so you yourself can read this and share the joy of going through this as well. I just wanted to say. The ionosphere is studied with dedicated ground-based facilities such as the High Frequency Active Auroral Research Program, HARP, and with satellite. A network of satellites measuring ionospheric disturbances are in place. A 1996 space experiment with a nearly 2-kilometer-long conducting line gathered electrical data in the ionosphere and then compared those with satellite data. Bing, ding. Okay. Oh, I missed one. Satellite data. The accuracy of modeling ionospheric activity between satellites is low. Modeled electric data are off by as much 140%, and I'm not even going to try and pronounce that name, in 1989. Wow. The accuracy of modeled ionospheric activity between satellites is low. All right, that's 140%. That's a lot. That's notable. All right. On the ground, HARP has been in operation in Alaska since 1993, and the reference there is 97. That facility is designed to transmit radio frequency electromagnetic radiation into the ionosphere for communication with submarine, with the electrolytes in the ocean acting as an antenna. HARP is also suited for ionospheric studies. HARP experiments are designed to study the structure of the ionosphere and for determining practical applications of wave propagation such as radio signaling. Results have included techniques to produce very low frequency and extremely low frequency, VLF, ELF, that's negative 30 hertz to 30 kilohertz radio waves. Reference in Cohen 2008. Lightning channels broadcast electromagnetic radiation in the VLF range, and HARP can duplicate this VLF. HARP has also been used for magnetotelluric surveying. What is magnetotelluric surveying, you ask? Well, in magnetotelluric surveying, both electrical and magnetic fields are used for remote sensing to determine the electrical resistivity of an area and variations within it, according to an empirical equation, this one here, where that's not a P, but it's this like a rho, I think that is, that's a Greek letter like rho, is the resistance of ohm meters, that's ohm, that's another Greek letter, M. F is frequency in hertz, E is the electric, hold on, all right, hertz. E is the electric field tensor in volts per meter. That's V per -1 meter, negative first, or whatever. And B is the magnetic field tensor in nanoteslas. It's NT, small nt. So nanoteslas is the magnetic field strength of the Earth, and not of the Schumann resonances, just FYI. HARP can generate magneto-telluric signals and was used as the transmitter for a proof of concept controlled source radio, here's a mouthful, oh my God, controlled source audio magnetotelluric survey, holy crap, CSAMT, in Alaska in 1999 and 2000, prospecting for petroleum. Westcott and Sentman, 2002. This is a new trend. Most magnetotelluric surveys have historically used natural fields, and that's Simpson and Bayer, 2005. Simultaneous measurements of the geomagnetic field and of telluric currents are used to calculate a value for the electrical impedance at depth to explore subsurface features. 3.2, which would be 9.2 for me. Lightning strikes. Electrical charge is transferred between the ground and the atmosphere during lightning strikes, and the tops of storm clouds close an electrical circuit with the ionosphere. Lightning discharge is energetic and creates plasma that we see. The first pulse of lightning occurs as charges within the cloud consolidate to form a strike leader, and plasma from the ground rises up to meet leader in that cloud. The next pulse comes from the cloud to the ground. The process repeats with alternating pulse initiations between ground and cloud. A lightning strike is a combination of about 30 pulse events, each lasting nanoseconds, and its overall duration is on the order of milliseconds, and the reference is Uman, 1994. The bulk result is a negative charge given to the ground. Peak electric current is 99 plus or minus 7 kiloamps, measured by quantifying remnant magnetization of the ground and calculating the peak magnetic field. And the reference is Verrier and Roche, 2002. Oscillation signal frequencies are of the order of 10 to the negative third megahertz, MHz, to 10 to the third megahertz. And so it looks like there's a negative in front of the 3 there, and that's a positive. All right, so that's a span of an order of -3. That's 1,000. 1,000 would be an order, that's a million. That's an order of a million. All right. Going from the -3 megahertz. Okay, just so we understand this. The previous data have been normalized to a 10-kilometer distance, and higher frequency signals are known to attenuate, with some dry lightning and strikes which ignite fires. I get you. A positive charge is given from the cloud to the cloud to the ground. The magnitude of charge carried with positive cloud to ground strikes is measured by the presence of aerosols and smoke, and that is references Nichitiu et al. 2009. Lightning strikes can also cause transient changes to the geomagnetic field, and it's Verrier and Roche, 2002 is a reference. Lightning can occur in various weather conditions, including thunderstorms, dust storms, and tornadoes. And the reference is Barr et al. 2000. Telluric currents arising from this phenomena ought to have frequencies of 10 to the negative third megahertz to 10 to the third megahertz. Again, it's a range of 1,000,000 there, based on, or an order of 1,000,000, I believe it is, based on the NS to MS variations recorded in lightning phenomena. I'm not sure what those are, the MS and NS. These are the same frequencies that a direct flash of lightning will display. Induction is localized, and portions of large buildings and towers are frequently subject to induction when they are struck. And the reference is Hussein et al. 2003. Compared data from several structures, and the average magnitudes are between 7 and 12 kiloamp, with magnitudes between 20 to... Okay, average magnitudes are between 7 and 12 kiloamps, with peak magnitudes from 20 to 20 kiloamps. Our next one is Whistler induction, one of my favorites. Whistlers give you, let me just say this. Where am I? Whistlers, for those who've been around for a while, Bradley and maybe a few others of you will know this. Whistlers, I pointed this out, that those are the odd spherics, and whistlers will give you those odd kind of curvy things in the atmosphere on the spectrogram. So that's why this is, just heads up, peeking up on you for the oddball. The Ezekiel's wheel, right? Ezekiel's wheel, that's whistlers is causing that. Just in my professional, since I've gotten donations, I guess I can call myself a professional. In my professional estimation, the Ezekiel wheel shapes get caused by whistlers. In lieu of any other explanation, you got a better explanation, fine, I'd love to hear it, but that's what my humble estimation of that is. Lightning discharge heats the air and creates plasma. Yes, it does. The entire lightning channel radiates electromagnetic energy. If in the radio frequency, it is called a radio atmospheric signal or spheric. If the plasma from lightning discharge travels along geomagnetic lines, the resulting radio frequency disturbances are termed whistlers and are named for the sound which this interference makes in telephone lines, as first described in 1919, and that's reaffirmed by Schlatter in 2008. The sound was attributed to lightning phenomena in 1953, and that's the year of Schumann right there. Whistlers typically occur in the ELF range of 3 Hz to 30 kilohertz. Reference Barr et al. 2000. For example, observations made from Antarctica at 22.3 kilohertz show common changes in amplitude of 3 decibels to an artificially transmitted signal with duration of around 30 seconds. These changes were associated with Whistler activity, and the reference is Helloel et al. 1973. The propagation of whistlers along geomagnetic flux lines can induce changes to local magnetic fields, and these can cause induction of human-made conductors and ore body. Whistler plasma. Whistlers are caused when plasma from lightning travels along the geomagnetic flux lines. The magnitude of the electron density striking the Earth is on the order of 10 to the 4th electrons per centimeter squared. Right? This is density. During Whistler events at the equator, poleward densities should be higher as the flux lines there are more inclined to the Earth's surface. That's Schlatter, 2008. Volcanic lightning strikes. And this is also one of my favorites, kind of up there in the top, the volcanic lightning strikes. An electrical response in the ground as lightning strikes during volcanic eruptions has been described in Aizawa et al. 2010. That's a reference. They describe magnetotelluric data from Sakurajima volcano in Kyoshi, Japan, from May 2008 to July 2009. Magnetotelluric pulses were recorded coincident with several strikes. Generally, volcanic plume heights where volcanic lightning has been observed are distributed bimodally. Plume heights 1 to 4 kilometers and plume heights 10 to 12 kilometers. In the former, volcanic lightning is due to vent processes, and in the latter, volcanic lightning is due to stratospheric processing. And the reference is McNutt and Williams, 2010. Occurrence of volcanic lightning increases with height in the stratospheric plumes, and peak currents greater than 3,000 amperes have been observed, and the reference is Bennett et al. 2010. Ash erupted from a volcano is electrically charged. Whether a circuit is made between charged ash and the ionosphere has not yet been reported. Low frequency, and this is 30 kilohertz to 300 kilohertz, spherics are reported. As with the meteorological lightning events, but the emission spectra of the flash itself has not been. Likewise, the author has not found reports of the magnitude of electrical discharge during volcanic lightning. So they're looking for it and they haven't found it. James et al. 2000 have described a mechanism for ash charging. In a series of experiments, ash-sized particles were ground from several crustal rock samples in a non-conducting sample holder. The materials developed charges of both polarities, generally based on the chemical composition of the particles, with the net charge of approximately 10 to the negative fifth to 10 to the negative sixth coulombs per kilogram, and that's CKG1. Their data are consistent with measurements taken previously within ash fall plumes, and the reference is James et al. 2000. They attribute the charge in the ash to fracture charging called fractoemission, where electrical charge is caused in a fracture as electrons are distributed unevenly during fracture processes. Lightning in volcanic plumes is controlled by topography and wind directions, with negative strikes, negative charge carried to the ground, and positive strikes and positive charge carried to the ground, evolving over the course of an eruption. The reference is Hoblit, 1994, or occurring simultaneously. The role of water in the magma and its influence in volcanic lightning is still an open question, though the occurrence of volcanic lightning is not related to latitude and hence is likely not related to the ability of the air to hold water. The reference is McNutt and Williams, 2010. And last section. Storm charging. Terrestrial electrical fields occur during storm activity. A vertical field on the order of 100 volts per meter to the negative first and a current density when they do this, it's negative meter, -1. It's I think it's a centimeter is the next one down. I just would like to say that. -2 is a millimeter. You know, that's what these numbers there are. It's the scale that they're going down to, just so you know. Has been measured during thunderstorm activity with water droplet interactions in clouds, perhaps serving as the source of the initial negative charge buildup. These may induce a positive charge in the ground. In thunderstorm clouds, the negative charge at the bottom of the cloud is offset by a positive charge at the top portion, in the top portion, that together form a conductive circuit flowing upward through the stratosphere, also called a thundercloud cell. In reality, negative charge is flowing downward. The current has been experimentally determined to be around 0.7 amp per thundercloud cell. And the reference is Troshikov, I think, et al., 2004. Current flow in a thundercloud cell accounts for about 96% of the electrical activity of the storm, while lightning discharges account for a minority, around 4%, that's small. Electrical charging of storm clouds is offset by charging of the ocean surface, where daily electrical ocean surface variations are consistent with the daily change of the total area occupied by thunderstorms. And the reference is Troshiev et al., 2004. Electrical frequency spectra in the ground form electrostatic storm charging are not reported to the author's knowledge. Okay, that's a lot to go through. If you stuck with me through all of that, thank you very much. You know, this is a pretty substantial reading to get through. You know, so fortunately for you, you just got to listen to me stumble through it, and fortunately for me, it'll sound better when I edit it. So on that cheery note, thank you all very much for being here. This is like almost 40 minutes, as it is. I very much appreciate everyone being here. You know, I said that, and you know, it's times are tough for everyone, you know, and if you need to, I just want to say, if you're watching this and you need a little extra battery backup for your heart, just kind of picture mine and like just kind of like a filling station, a battery for your heart, you know, like that's, you know, or any of your other, you know, chakra points, you know, because I talk with Source and, you know, I got that part. So just, you know, remember the purple amethyst flame will incinerate at anything. You know, any ties that you have with people that need to be cleared up, and the, you know, your lowest densities that need to be clearing, you know, like just clear them up and don't question if the universe is pointing you in a direction, if it is the right direction. The universe is pointing you in that direction because you need to go in that direction. And the longer you wait, the worse it's going to be when things get ripped from you that you don't want to let go of willingly. You know, remember, the truth does not hurt. Having the lies ripped away that you've been, you know, using as a, you know, a cover, those getting ripped away, that's what hurts. Honestly, you know, having your lies pulled from you is what hurts. The truth is what's going to heal you. And just let you know that. And, you know, it's you know, that's one of the things that keeps us all together here as humans, is this going through pain, moving through it. But moving through it is what separates, you know, being in pain is what unifies us all. But moving through that is what separates some of us. I think that's a good way to put it. And that's a great way to end on that cheery note. That is actually a legitimately cheery note, I think. All right, so thank you all for being here. I appreciate everyone for your love and your support, your comments. Remember, like, share, comment, subscribe, and tell your friends. Share this video. Let everyone know. It's free information for everyone. You know, it's free for me, it's free for you. All right, so on that cheery note, Much love. I'm so glad to be finally done with this, and have a great rest of your day with this particular chapter. Oh my God, I started it on the 7th, I think, getting the information together. I started working on it on the 8th, and then, oh good golly, it's now almost another month, and it's done. I'm done. All right. Thank you. Much love. I will see you hopefully in the live cast, maybe tonight. I don't know, soon. Who knows? Anyway, have a great rest of your day. Namaste. Much love.